Alright, the first problem is on 6.4 homework help is one where we haven't done one like this before. We got to graph this function. Now the function that they give us is y equals 2 sine of x minus pi over 2. Now we could graph the regular sine function, because the regular sine function starts off at 0 right here, and then it goes up. So it goes up like this, and then because the sign on the unit circle is the y value, so then the y value as you go around here goes down, and then the y value starts to go back up after it reaches its lowest point. So it's just going to be a reciprocating function like this, and then we can figure out how this is stretched. So it's going to go up a little higher, and it's shifted over 90 degrees. So we're going to shift it to the right 90 degrees. We could do it that way using our function transformations, but I think it's easier just to plot a couple points. I think it's quicker and easier, and I'll show you what I mean. Start thinking about a table. So start thinking about an XY table where we're going to start off with the point 0. When you plug in 0, you get 2 times the sine of negative pi over 2. Now, the sine of negative pi over 2 is on your unit circle. That is down here. Negative 90 is rotating this way to that point right here. At that point, the sine's y value is negative 1, so it'd be 2 times what the sine's value is, which is negative 1, which gives you negative 2. So what that means is my function starts off at this point right here, 0, negative 2. So the next thing to do is to do one more point. Now what I'm going to do is I'm going to choose the next point as 90 degrees, because typically on the unit circle we want to go by increments of 90, because we start off at 0 and go to 90 and then 180 and so on. So the next point I'm going to do is plugging in 90. So when I do that, I get 2 times the sine of 0, because 90 minus 90 is 0. The sine of 0 is 0, so it's 2 times 0, which gives you 0. So this thing at 90 degrees, which by the way is pi over 2 in this graph, which goes by units of 1, so it'd be 1.57 in your calculator. This graph is 0. From this point, you can kind of follow the pattern. At pi, then, this thing's going to reach its maximum value, which is 2. So at pi, which is 3.14, this thing goes all the way up to 2. And then at 3 pi over 2, which is the next one, this thing, which is 4.7, goes back down to 0. So right here goes back down to 0. And you can follow that same pattern to be able to graph this whole thing. And it's going to look like this. So click add points and add the points and try to get them as close as you can to these points, and then click connect and then click score or submit the answer. And you might need to then allow drag these points a little bit to make sure they're as close as can be to these actual ordered pairs here, and then hit submit again, and it should accept it at that point. Usually didn't work the first time for me. It was after I dragged them to a more precise location that it worked. Alright, the next problem is kind of a weird one, but it says I have a radius of 5, and then it says that it gives me two different graphs here, and it says first the angle theta in radians is given as a function of time right here. So what is the value of theta when t equals 1? So it's saying when t equals 1, I get a value of theta of 1, so mine's easier than some of your guys's. My theta is 1, so what that means is I can set up a reference triangle with an angle of 1 right from this graph now, where the radius is 5, and I want to find my xy ordered pair. So I would do sine of 1 equals opposite over adjacent, multiply both sides by 5, and that gives me my y value, 5 sine of 1. And my x is going to be the same thing, but it's going to be 5 cosine of 1 if you set up and do cosine of 1 equals adjacent over hypotenuse, so multiply both sides by 5. So here's my xy ordered pair, which for me gives me the coordinates 2.702, 4.207, and make sure you keep, like at least 3 decimal places. Okay, the next problem wants us to determine the frequency of this. Now, the period we know is 2 pi over b. That's on our formula sheet. So in this case, my period is 2 pi over 13 pi, which the pi's cancel and I get 2 over 13 for my period. The frequency is just 1 over the period. So basically, I just need to reciprocate the period. I can make this 1 over 2 over 13 and just flip it and get 13 over 2. So my frequency is 13 over 2, just the reciprocal of the period always. Okay, the next problem gives me this function right here, and it gives me 2 points on the graph, and it wants me to write the function. So what I'm going to first find is the amplitude. So when I go to fill this out, I'll use y instead of f of x, but it doesn't matter. Y equals, the amplitude in this case is 3. because the amplitude is the distance from the center to the highest point or the lowest point. And then I want to find b. The period is equal to 2 pi over b. So in this case, the period of mine repeats from -2 all the way to 3, it looks like. So my period would be 6. So now I can solve this by multiplying both sides by b and dividing both sides by 6. And I end up getting b equals pi over 3. So my b is pi over 3. And then times x minus c plus d. Now my d is 0 because it's not shifted up or down at all, as you can tell from the graph. The graph is right here. It's not shifted up or down at all, so my d is just going to go away. But I do want to find my phase shift. Now the regular sine function goes like this, as we talked about. It starts off at 0 and goes up. So basically I can see that I've taken my regular sine and I've shifted it back 2 units, for example, or I've shifted it forward 4 units. Either way is going to work. I'll go back 2 units. So to go back 2 units, I add 2. So I would add 2 to x. As we know, if you add 2 to x, it moves it back 2 units. So this is my answer right here. The next problem says the equation of the sine waves is obtained by shifting the regular sine function to the right 9 units. So if we shift it to the right, that's when we it's when we subtract 9 from x. And then we want to move it downwards 8 units, so that'd be minus 8 outside. And then vertically stretched by a factor of 5 is changing the amplitude in front or multiplying the function in front by 5 here. So here's my new function that has those transformations. Okay, the next problem then gives us this graph, and it wants to know the amplitude, period, and phase shift. The amplitude, once again, is this height from the equilibrium point to the top, which is 4. The period is how long it takes to repeat itself, which in this case is 2, because it's going up here and crosses 0, and then it's going up here and crosses 0, so it looks like in 2 full units it repeats. The phase shift then is... So then the phase shift is, in this case, 0, because the regular sine function goes like this through the origin and goes back up and back down. So this one's not moved over at all to the right or left. Next problem, same thing, wants the amplitude, which is always the number in front, which is 7. It wants the period. Now the period is always 2 pi over b, which in this case b is right here in front of x, which is 3 pi. So all the pi's would cancel and you'd get a period of 2/3. The phase shift is what we're doing to x, which this is a little confusing, but what I actually have to do to find the phase shift is I have to rewrite this as factoring out a 3 pi from x. So I have 3 pi times x minus 2 over 3 pi. It seems weird, but in order to figure out the phase shift, I actually have to get x by itself in terms of in parentheses, where I can see exactly what I'm doing to x alone. And if you could get back to this if you were to FOIL the 3 pi through, you'd see the 3 pi's cancel and I'd get right back to this. So the phase shift in this case is 2 divided by 3 pi. Now another tricky thing is you have to put this 3 pi in parentheses in the bottom, because otherwise Webwork is just like the calculator where it won't recognize this. It'll do, if you do enter it in like this, then it'll do 2 divided by 3 times pi. So Webwork recognizes it as 2 divided by 3 times pi if you enter it in like that. So be careful, and so does the calculator. So make sure you try that on your calculator to see the difference. The last thing is the vertical translation, which this thing shifted down 3 units. So I'm going to enter a -3 there. Okay, the next problem then gives us a sine function and wants us to write this function. So it's going to be the sine of something. Now the amplitude looks like it's 1, so I don't even need to write that in front. And then I need to figure out the phase shift. It looks like the period of this thing looks fine. It looks like it repeats about every 2 pi, because that's about 6.28, which we need to recognize is about 2 pi. So the period looks fine, because that's what the normal period is of a sine function. So if you want, you could do the period equals 2 pi over b. And in this case, the period is 2 pi, so that means our b is 1. So once again, when we write the sine function, we usually do a sine of bx plus c plus d. It looks like so far we have 1 for a and we have 1 for b. So, and this thing's not shifted up or down at all, so we have 0 for d, so we don't have to write that either. So all we're looking at is our phase shift then. Well, how have we shifted this over to the right or the left for sine? And to do that, we know the regular sine function goes up right there through the origin, so we can shift it to the right by that amount. So the question is, what is that amount? This is where it gets a little tricky. But that looks to be about 1.6. Because if you go by 1, 2, 3, 4, 5 parts of 2, is 0.4, so you're going by 0.4 every time. So 4/5 of 2, I guess you can look at it this way, 4/5 of 2 gives you 1.6. So that's about 1.6. Now you want to recognize what that is in the unit circle. So in the unit circle, this is 0, this is pi over 2, which is really about 1.57. So that's the spot we're at. And then obviously you want to know that this is 3.14, and this is 3 pi over 2, which is 4.7. So you want to know those decimal equivalences because a lot of times on a graph, you're going to want to know where these values are. So 1.57, so actually this is pi over 2. So that means we've shifted this over pi over 2. So I'm going to write x minus pi over 2, and that way we shifted it to the right by pi over 2. So that's my answer that goes right here. And then the last one is similar. It looks like once again it repeats about every 2 pi, so it looks like the period is fine. So when we write our function y equals, or f of x equals a sine of bx plus c, right off our formula sheet, we know that the amplitude once again is 1. We know that the period is 2 pi, so once again the period equals 2 pi over b, which the period is 2 pi in this case, so b must be 1. So we have 1x, and then once again it's not shifted up or down at all, so d is 0, and we just need to figure out how far it's moved to the left or the right. The sine function usually goes up right here. That's the point that's usually at the origin. So I want to figure out how far over that is. It looks like it's about pi. It looks like it's about a little over 3, because 3 would be right here, so that'd be about 3.14, which is pi. So it looks like I've shifted this over to the right pi, so it'd be x minus pi as my answer. And the last problem is pretty easy. It wants the amplitude, which we know is the distance from the center to the top or bottom, as long as you do the absolute value, which is 3. And the period is how the distance it takes to repeat itself. So go from any 2 points that are the same, like these 2 points here. Looks like this is about a little over 0.2, and this over here is a little over 2.2. So, from 0.2 to 2.2, you're looking at a period of 2. If you subtract 2.2 minus 0.2. All right, I hope this helps.